Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. This video discusses the flooding associated with the meteorite impact 12,900 years ago. The story is complicated because there were several meltwater pulses at the end of the Ice Age. At the peak of the last Ice Age, approximately 20,000 years ago, massive ice sheets covered parts of North America and northern Europe. With so much water stored on top of the land, the sea level was 120 meters lower than today. As this graph shows, the sea level did not rise smoothly. There were periods when the sea level increased rapidly, and scientists have tried to determine the source of these water pulses. The meltwater pulses started about 19,000 years ago, at which time ocean levels rose 10 to 15 meters in less than 500 years. A clearly defined increase of sea level rise occurred between 14,600 to 13,500 years ago, called Meltwater Pulse 1A. This water pulse increased sea level by 16 to 24 meters. The meltwater is believed to have come largely from North America because diatom fossils and sediments from East Antarctica showed that the ice in Antarctica began melting about 3,000 years later. The Missoula floods were cataclysmic floods that swept across eastern Washington and down the Columbia River Gorge at the end of the last Ice Age. The floods occurred between 15,000 and 13,000 years ago. Lake Missoula measured 7,770 square kilometers and contained about 2,100 cubic kilometers of water, which was about half the volume of Lake Michigan. The floodwaters carried large icebergs that scoured the land, creating scablands with giant ripples. The melting icebergs left the landscape covered with erratic boulders carried within the glacier ice. During the Ice Age, two massive ice sheets, the Laurentide in the east and the Cordilleran in the west, covered most of Canada and the northern United States. According to some accounts, humans migrated from Asia when an ice-free corridor opened between these ice sheets. The Cordilleran ice sheet was on top of a large volcanic province in British Columbia. There is a good possibility that a volcanic eruption under the ice sheet could have provided the meltwater for the glacial lakes Columbia and Missoula. The rate of sea level rise slowed during the Younger Dryas cold period, which started 12,900 years ago and lasted for about 1,300 years. The glacier ice impact hypothesis proposes that 12,900 years ago, a meteorite impact on the Laurentide ice sheet ejected ice boulders in ballistic trajectories, and that the oblique secondary impacts of the ice boulders liquefied the ground and created inclined conical cavities that produced the shallow elliptical depressions known as the Carolina Bays. The water ejected above the atmosphere created a fog of ice crystals in low Earth orbit that blocked the light of the sun and triggered the Younger Dryas global winter. From the number of bays and their energy of formation, it is possible to estimate that the total energy of the secondary impacts was approximately 6.35 times 10 to the 21st joules. This provides a rough lower limit of the kinetic energy transferred to the ejecta by the extraterrestrial impact. If an equal amount of energy was converted to heat, the size of the extraterrestrial projectile can be estimated as equivalent to an asteroid with a diameter of 4 kilometers traveling at a speed of 17 kilometers per second. Melting ice into water at 0 degrees Celsius requires 334 joules per gram. If the heat produced by the extraterrestrial impact was equal to the energy for producing the Carolina Bays, then 6.35 times 10 to the 21 joules would melt 1.9 times 10 to the 19 grams of water, which is about 1,900 cubic kilometers. This volume is comparable to Lake Missoula. The Younger Dryas was followed by another surge called Meltwater Pulse 1B from 1,500 to 11,000 years ago. Sea level may have increased by as much as 28 meters. The single extraterrestrial impact that created the Carolina Bays would not have produced so much water, but it is possible that the impact destabilized the Laurentide ice sheet and increased the rate of melting. Another possibility suggested by the Comet Research Group is that there were multiple impacts on the Laurentide ice sheet from a disintegrating comet, although the location of other impacts has not been found. The Mississippi's watershed drains all or parts of 31 U.S. states and 2 Canadian provinces between the Rocky and Appalachian Mountains. The Mississippi alluvial plain remains as evidence of the large floods at the end of the Ice Age. A fourth interval of rapid sea level rise between 8,200 and 7,600 years ago was identified by a decrease in coral growth in the Caribbean. This increase, called meltwater pulse 1c, has been linked to the catastrophic drainage of glacial lakes Agassiz and Ojibwe starting around 8,400 years ago, which released a volume of about 105 cubic kilometers. This pulse only produced about 1 meter of global sea level rise. Large-scale glacial melting essentially ceased by the mid-Holocene period about 6,000 years ago. Periods of rapid ice disintegration are known as Heinrich events. When icebergs drift and melt, the dirt that they carry settles onto the ocean floor as layers of sediment that help to identify Heinrich events. Glaciers that touch the ocean are very sensitive to ocean warming, which causes increased calving of icebergs. Warm oceans may be the answer to the energy paradox that attempted to find the source of energy that melted the giant ice sheets over North America. The mid-ocean ridge at the bottom of the Atlantic Ocean has been spreading apart for millions of years. New crust is being formed as lava is extruded to form an underwater mountain range. Iceland happens to be a tiny portion of the Atlantic mid-ocean ridge that is above sea level and continually experiences volcanic activity and thermal springs. The extraterrestrial impact that triggered the Younger Dryas cooling event released a volume of water equivalent to the Missoula floods that created the channeled scablands of eastern Washington, but the Earth's core may have been the source of heat that warmed the Atlantic Ocean and helped to end the Ice Age. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.